Welcome back, Trigonometry. I'm Mr. Carlson, and we're going to go through another great lesson. This is your actual first trigonometry full lesson that we're going to be doing today. So, I hope you're excited. If you're not excited, then just kind of grudgingly go through the video. But the first thing we're going to be doing is the bell work. This is a little bit more syllabus review as well. So just kind of really hitting home what's on my syllabus, and so that we are all aware of the expectations I have for you for online students, as online students. So we're going to do that. The fourth thing we're going to do, because I'm going to skip these two because we're not in class, this next thing we're going to do is the objective and essential question. You should be getting your notes out, being prepared, so that you can actually write down your Cornell notes. Remember, I will be checking Cornell notes, your focus notes, by the end of this week. You will have to submit pictures for your notes by the end of this week. Okay? So make sure you're writing notes down throughout this video. And then we are going to be going through angles and radian measure. What are the differences? Is there a difference between degrees and radians? What are actual angles? How are radians useful in trigonometry, and so forth? So we're going to go through angle measure, degrees and radians, and what we call coterminal angles. After that, we're going to summarize with closure and some homework there. If you're not on Math Excel, you should be on Math Excel. So if you're watching this video and you are still not on Math Excel, I want you to first pause the video. And then second, I need you to either show up to the Google Meet link with whatever day it is, from 11 a.m. to 12 p.m. And then you also need to email me saying, hey, I'm new, I need an access code, or hey, I'm not new, I had you last year, but I'm not so sure how to get on Math Excel. You need to do that right away. This is real school, guys. Your grade will suffer if you are not paying attention, if you're not watching these videos in its entirety. These are useful information throughout the whole video. It is very, very useful stuff. I can't let you guys just slack on these videos when I'm trying to explain something. It's not respectful to me. It's not respectful to you and your education. It's just not right at all. So get on Math Excel if you're not on Math Excel, because your homework tonight will be on Math Excel. Let's go through the syllabus review really quick. Real quick, remember the syllabus. If you're watching this on Wednesday, because this is where the video is, then that's fine. Remember, your acknowledgement form for the syllabus is due then today, 8/5 by 4 p.m. Okay, I will be grading them on Wednesday, 8/5 by 4 p.m. If you have yet to do the syllabus acknowledgement form, go to your syllabus that I sent you and then click on that link. Also go to Google Classroom on the classwork page. It's at the very, very top. Just click on the online syllabus. It'll give you the syllabus and then the link's right by it. Click on that form and then fill out the form with the parent or guardian. Let's go through it. How much are homework quizzes worth? Should be 10 points. They are worth a small amount, but they are worth some. Okay, this is not the actual, actually, I'll get to that later. Yeah, so 10 points. Homework quizzes worth 10 points. Quizzes? Class? 50 points. 50 out of 50. Tests, how much are they worth? 100 points. They are worth 100 points. 100 big ones. 2, do I grade individual homework assignments on Math Excel? That is a no. However, okay, if you had me before in the past, this is something I'm changing, probably from now on, even if you're in class, is that I will be grading an average score for participation on your Math Excel homework assignments. So no, I don't grade the individual homework assignments and individually put them in the grade book. So if you got, a 90% on one homework assignment, I don't put that 90% into Synergy. I don't do that. What I do though, instead of that, is I take all the homework assignments on Math Excel for that week, and I basically average them up. So I just add them all up, divide by 3, and then I average them. And if it can be rounded to either 100%, 50%, or 0%, that percentage, 150 or 0, 10 out of 10, 5 out of 10, or 0 out of 10, those points, that percentage, will then be put into the grade book. Okay, and that's weekly. So no, you don't technically need to do the assignments, but Yes, you technically do, at least some of it, because it is worth a slight participation grade. Okay, so make sure you understand that. Are you allowed to listen to music on your phone at any time during my class? Well, technically, yes. You're probably listening to music right now, but technically, no if you're on campus. So, and the reason why if you're on campus is because it's just disrespectful. Now, obviously, I'm not there to hound you, so feel free, listen to Taylor Swift. Be my guest. She has a new album out. It's amazing. What procedure must you follow in order to leave my class for the restroom? Just get up and leave. So obviously on campus you'd have to have your passport, but right now it doesn't apply. And what is my number one expectation for every single student? Ask questions. If you're not asking questions, then I don't know if you understand something or not. You need to email me. You need to, go to Math Excel, click on the question help, ask instructor button, and so send me an email with that problem that you're struggling with so I can help you. You need to get on the Google Meets link, say, hey, I don't understand this question. Can you help me? And I will try my very best. Okay, I'll try my very best to get to everyone. That this is a class that is 40 people. Okay, there's 40 kids in this class. Okay, so I'm trying to provide as much resources as possible for you so that you can utilize those resources without coming to me first all the time. But I am flattered, and it is my expectation that you ask questions specifically to me if you don't understand. So, without further ado, let's get started. You should be having your notes out and writing down the essential question here. That is the question mark one, the one that's italicized. This is your essential question. Make sure you write it down. Here are my objectives. Okay, I can use degree and radian measure by measuring angles. Yeah, you can. Hopefully you'll learn how to do that at the end of the lesson. I can convert between radian and degree measure by unit conversion formulas. Yes, I can find coterminal angles by adding and subtracting 360. We will learn all of that, plus additional stuff, in this lesson. So, are we ready? If you need more time, pause the video. I'm moving on. So, first things first, this is going to be a rather lengthy lesson, probably one of the longest lessons that I will have in this class. Easily. It'll probably go past an hour. I don't know how long it will go, but it'll probably be an hour and a half just because it's so long. But I want to kind of build on what you've sort of already learned in geometry to kind of make a case, if you will, for trigonometry and why it's important, why it's helpful, why I love it, and so forth. Okay, so think of this lesson as like the first lesson is the very foundation for trigonometry because it really is. So this is an awesome building if you've ever been there. The San Francisco Museum of Modern Art was constructed in '95 to illustrate how art and architecture can enrich one another. Pretty cool, right? So the exterior involves geometric shapes such as like obviously the circle, and there's like a little triangle inside. Although there are no windows, natural light streams in through the truncated cylindrical, not a word you say every day, cylindrical skylight that crowns the building. So the architect basically worked with this scale, a scale model of the museum, and observed how the light basically shined in, and then he built like a bigger model for it. That's freaking crazy. So it maximizes the sunlight using angles. So angles play then a critical role, not just in modern architecture, but really just everywhere we look. I mean, the shadows we have, even when you're drawing art, maybe in Mr. Power's class or another class, when you're drawing art, you have to measure angles. If you're building something with wood, guess what? You have to measure angles. If you're spray painting something with like straight lines and you're trying to draw bubbles or whatever on like a piece of paper, you have to measure angles. Maybe not technically, but you're using angles in one way, shape, or form. Okay, so they are a fundamental part to trigonometry, specifically when it comes to clocks. So you look at a clock, okay, and I literally had a student last year saying, I don't even know how to read an analog clock. And I'm like, what? It's like they're just all about that digital life. And that's true, iPhones are great, but you should probably learn how to read an analog clock. Okay, the clock hands form an angle. This is an angle. These are rays. Technically, the clock hands are rays, whereas this is an angle, and we can measure what that angle is. In fact, some of your homework assignment questions will be doing that, especially if you're in honors. Okay, you'll be looking at the clock and you'll have to be doing that. So if you're in honors, be on the lookout. There are great videos, though, on Math Excel to help you with that. So what are the basics of trigonometry? Well, first of all, it comes from the Greek word trigonon. Trigonon. I'm probably mispronouncing it in a little bit because I'm white, but it does mean triangle, and metron, which means measure. So it's literally the measure of triangles. We have a whole class dedicated to the measure of triangles. Freaking crazy, right? And really just the definition, what it means is just the study of the measurement in triangles. That's what it means. So many angles in trigonometry are located what we call in standard position. What is standard position? An angle is in standard position if it follows these two criteria. So its vertex is at the origin in the rectangular coordinate system, and its initial side, so this is what we call the first side. The first side lies along what we call the positive x-axis. Now, I'm underlining this vehemently because this is so important. Okay, and every single time I emphasize it, it just so happens students get it right. And every single time I don't emphasize it, it just so happens students get it wrong. So I emphasize it for good measure. So this is sort of what you guys did in geometry, where you had two rays, two segments, two rays, and you kind of had one ray, you went through this angle called theta. Remember from our first video, I'll kind of blow it up here. It's just like a circle and then a little line through it. This is what we call theta. Okay? That angle measure is whatever angle measure that is to get to what we call the terminal side. That's the side that I finish, the side that I end at. So this is the initial side, the first side that I start with, and this is the terminal side, the side that I end with. And this is kind of like the pivot. The vertex is like the pivot point. All right, let's move on. Again, this is kind of geometry review right here. Angles in standard position. What does it look like? So in angles in standard position, this is sort of what we have. So again, if I put those two things, the initial side and the terminal side of the vertex, not just in a random plane like you did in geometry, but what if I put them on an actual XY plane? If I put them on an XY plane here, this is what it will look like. So my initial side here starts on the positive x-axis. Always, always, always. Positive x-axis. And then it goes all the way to my ending side, which is my terminal side. This is what we call alpha. So I'll write that down for you. That's alpha. Now notice the vertex is what we call the origin. Now, you might have done some trigonometry on an XY plane in geometry, where you translated, rotated, and reflected on the XY axis, but the majority of your geometry days were done on just a random plane, not on the XY plane. Okay, they were just kind of done in outer space, if you will. But now we're actually introducing the XY plane and doing geometry on the XY plane. If you do geometry on the XY plane, guess what? Boom, it gives birth to trigonometry. So it's really algebra and geometry mixed. Some of you in Algebra 2.2 at the very end, when we did trigonometry, you were like, why are we doing trig? This is algebra. Blah, blah, blah. That's true, but if you take geometry, something that you should have already learned if you've taken algebra at that time, and you mix it together and breed it with algebra, boom, you get trigonometry. Okay? So our alpha, theta, or alpha angle measure, whatever that is, it doesn't matter what I name it, but it could be theta, it could be alpha. But in this case, our alpha measure is in standard position, and alpha is also positive. It is positive because it is going counter clockwise. So I'm just going to say counterclock. Whereas in this scenario, our other angle measure, in this case it is theta. You guys should already be familiar with theta. Our theta is going kind of under. So it's not going over, it's going under the x, y axis. But notice it's still, what is it? The positive x, y axis, no matter what. This is what we call a negative angle. So this would probably be this angle measure right here is probably like negative 120 degrees. Okay, probably. I'm just kind of guessing. I don't know if it is or not. But this is a negative angle, is when we go clockwise. Okay, and it's kind of counterintuitive because you think like, oh, clockwise it should be positive because we're always using it, but and it's going forward in time. But it's actually not. So a negative angle is clockwise, a positive angle is counterclockwise. If I go over, it's positive. If I go under, it is negative. All right, let's go to town. What is degree measure? How can I measure angles in degrees? This is the most common way to measure angles. So a complete rotation of a clock is 360. Now think about that. If you have a complete rotation of a clock, how many minutes have passed? You're probably thinking, well, obviously 60 minutes, right? And there's 60 seconds in each minute, right? You feel me? Now, of course, that's 3,600 seconds if you multiply them together. It's 3,600 seconds, sure. But notice this down here. Notice it. 360 rotations. A lot of 60s. Why is that the case? Why is it the case that there's just so many 60s? Well, it's because back then they actually measured time, they measured angles with degrees, and the Babylonians, the ancient Babylonians, literally 2,000 years ago, 2,500 years ago actually, way back then, they measured things, geometric shapes, in degrees. Okay? We have a base 6 system in mathematics because of the Babylonians. 60. 360. Why is it base 6? Because you can divide it by 6, 12, 2, 24. You can divide it by 60. You can divide it by 120, and so forth. You can divide it by 240. And so it all goes into it because it's all base 6. Why did the Babylonians do that? Fun fact in history is because they felt like it was one of the numbers that had the most factors attributed to it. We have base 10, maybe because we have, five fingers here, so we have base 10, maybe. But I think there's other reasons for base 10. That's kind of a fun fact. Regardless, there's two ways to do measuring angles. Two ways to measure angles. Number one, degrees, which we're going to go through, and number two, radians. All right. Now, measuring angles, degrees. You'll see something like this and you're like, what? Don't freak out, okay? I'm actually going to go really fast. You don't need to write this down, by the way, so don't write this down. This is what we call the unit circle, okay? But we're not going to be doing this right now. Essentially, you will have an XY plane. Okay, you will have this XY plane, X, Y, and you can actually make this full revolution here. So if I go throughout this full revolution, if I continue the theta all the way around, that means theta would then equal 360. If I did theta right here and I stopped right there, that would be my terminal side. This is my initial side, and that would be your 90-degree triangle. You following me? If I did theta all the way over here and I stopped there, my initial side is this. My ending side is this. What's my angle measure? 180. And it just so happens that that's a straight line. From geometry, 180 degrees is a straight line and always will be a straight line. So this is kind of how you measure angles. And when we are measuring angles, it kind of plops implicitly a circle onto our XY plane. And so we are going to be dealing with circles a lot. We are going to be dealing with the XY plane a lot. Let's get into classifying degrees. This is, again, technically review still. There's kind of 4 ways to classify an angle. This is geometry. If you have an acute angle, it's between 0 and 90. A right angle is 1/4 of that rotation. It is just 90 degrees. An obtuse angle is between 90 and 180. And then a straight angle, like I said, like I already showed you, was just half a rotation, a semicircle. You see this semicircle here, half rotation, straight angle. All right, so we'll be using the notation such as theta equals 60 degrees. So basically, we're going to be using this notation a lot, this theta. So if you do your zeros with the little line through it, you should probably stop that because you're going to get really confused fast. Theta equals 60 degrees to refer to an angle whose measure is 60 degrees. Okay? It is very, very precise, like it says, but perhaps maybe even cumbersome, but it doesn't matter. We're going to be using theta. Now this is something that's new because you haven't had geometry on the XY plane before, at least trigonometry on the XY plane. And so we do have specific types of angles, what we call quadrantal angles. Quadrantal angles are those whose angle lies on one of the axes. Okay, and these are the angles: 0, 90 degrees, 180, 270, and 360. Sorry, I'm going to go back here and I'm going to show you what that means. What it means is this. So this is 0 degrees right here. And if I go right here, this is 90 degrees. If I go right here, this is 180 degrees. If I go right here, this is 270. And if I go right here, I did a full revolution, right? So this is also 360 degrees. Notice how this is sort of a circle, sort of a circle, but you get what I'm saying. So that's kind of these quadrantal angles. So that is a quadrantal angle, 180 is quadrantal, 270 is quadrantal, 0 and 360 are quadrantal angles. We're going to actually review those a lot more as the weeks kind of go on. So I'm just going to leave it at that and move on. Another way to measure angles is what we call radian measure. This is completely brand new. And this is a very, very, very important definition. Okay, 1 radian. When I say something is 1 radian is the measure of the central angle. If you don't remember what a central angle is, this is XY plane on a circle. Let's just say this is theta right here. Notice how this is the central angle. Okay, you remember that from geometry? The central angle of a circle that intercepts an arc. What's an arc? An arc equal in length to the radius of the circle. So that means this right here is your arc. Think of it like a pizza crust. So if this is a pizza, I'm taking this out. That pizza crust is the arc length. Now when I say length, that means it's a distance. What does that mean? That means if I go 1 radian here, that means this must also be 1 inch in length. Okay? So if this was 1 radian, that would be 1 inch in length. Does that make sense? 1 inch pizza crust. Sounds awful. Okay? Sounds really just crummy. Who wants that? This is a better picture for you guys. So again, if this is a circle, this is your vertex or your center right here. This right here is 1 radian. If that is 1 radian, that means this right here is what we call the radius, obviously. It should be obvious. That is your radius. This R is also your radius. So these radii are actually equal. And let's just say this is theta. When this is 1, that means this and these sides all equal the same thing. Okay? That's 1 radian. The intercepted arc, this arc, that kind of is embedded in between your 2 radii, and the radius itself are equal. Okay? All right. So these are other examples. I'm going to briefly go through these as well. Let's look at beta. That's beta right here. So this means if this is your radius, your initial side, and you go beta degrees, however many degrees that is, this is technically your three different, this is your two different arcs. So this is one arc, and this is another arc. Okay, so two pizza slices. You feel me? This is also R, by the way. This is also R. They should have, if you did it perfectly down the center, okay, then that means you have done it correctly by virtue of making correct arcs and making the perfect pizza slice. Okay? And then right here, this is gamma. So gamma, this is intercepted 3 different times. So 3 pizza slices. And again, this segment is R. That's your center. And this segment itself is R. Okay? All right. So 2 central angles measured in radians. And then you got the 3 central angles measured in radians for gamma. All right, what is the formula? There's a formula here. It's called theta equals S all over R radians. Now, they say R is the radius, and then S is the length of the arc. Okay, so this whole length, the pizza crust, is S. Theta is your angle measure. And then R, of course, is, like I said, your radius. Okay? So this is our formula. Now notice I have radians here. That's technically a unit measure. Okay, that is your unit measure here. I know my handwriting is awful. Those of you who've had me before in the past can definitely attest that this is not usually what my handwriting looks like. So new students, I apologize. But this is unit measure here. Okay, we literally just say radians for the unit measure of radians. All right. You don't need to write this down really, but 2 pi, we're going to start introducing pi radians. I don't think this is actually true, but I think it may be true that there's a reason why you call a pizza a pie, or why you call a pie itself, because it's circular, a pie. Okay, because a circle has to do with pi. When you go 360 degrees around, if I went 360 degrees with theta all the way around, that would be, like I said, 360, but also be radians as well. How many radians? 2 pi radians. So 360 degrees corresponds to 2 pi radians. 180 degrees corresponds to pi radians. 90 degrees, 1/4 rotation. So if this was right here and I rotate 1/4, get my little right angle, that would be up here, pi all over 2. We're going to continue this a lot more. I'm not going to confuse you guys too much on this. You can also get decimal versions of it, but I'm not going to continue with that. So because I'm going to review it later. So let's actually go through an example here. So example 1, computing radian measure. How do I actually compute radian measure? Let's do that. I'm given an example, a central angle, theta, surprise, in a circle of radius 6 inches intercepts an arc of length 15. What is the radian measure? So the first thing I usually do is do a fancy brace. I like listing out my variables. Okay? I don't know theta, my radian measure. That's what I'm trying to find. What is the radian measure of theta? I don't know, question mark. But what is S? Well, it tells us the arc length is 15. This is S. So that means I'm going to put 15 inches. And you better believe I'm writing the units. That's important. Now, 6 inches is my radius. So that means R equals 6 inches. Right? Okay. Now that means theta equals, using my formula, S equals, or S all over R. This is my formula. It's not my answer. I'm clouding it because that's my formula. So when we solve this, now watch, pay attention, 15 inches here, because that's my S, and I plug in R, which is 6 inches. And then, of course, the inches go poofy, and this equals 2.5 radians. I'm going to abbreviate RAD. So how many radians do I have? I have 2.5 of them. Now you're maybe thinking, whoa, you got rid of the inches, but then you just popped out of radians? Yes, actually, I did, and there's a reason why I did that, and I'm going to show you later. There's a reason why these radians just kind of pop in. Now think about it. Your arc length is 15 inches, but your radius is 6 inches per radius. Okay? It's per radius. So if I want to divide this evenly, this would then become radians. I'm going to show the math more later, but here's what it actually looks like. Whoops. Here's what it actually looks like. I'm going to erase all this. And so this is what, if I wanted to draw it out, this is what it would actually look like. So what's my theta, guys? I already said my theta is 2.5 radians. Okay. Remember, radians are an angle measure, just like degrees. Radians are an actual angle measure. Okay? All right, 15 inches, that's 6 inches. How many radians? What is this? We said it was 2.5. Perfect. Let's clear. Now, conversions. Conversions. This is very, very important. Very important stuff indeed. I need you guys to write down this stuff because this is really what we're going to spend the majority of our time on, or at least maybe half of it on. Conversions, radian and measure degrees. What if I have degrees but I want radians? What if I want radians but I really want degrees? What if Math Excel gives me radians but I need degrees? How can I convert between the two? Well, we use the basic relationship that pi radians equals 180 degrees. Remember that? So when I have this right here, I have a circle, and if I go all the way over on a theta, this is 180 degrees. My quadrantal angle on my axis, part of my axes, right? This relationship here actually gives us the helpful formulas. Number one, to convert between degrees to radians, I multiply degrees by pi radians all over 180 degrees. Now, if I want to go from radians to degrees, I just flip and do the opposite, 180 degrees all over pi radians. Now, notice my use of units here. Radians, radians, degree symbol right here, degree symbol right there. Okay? Awesome. Now, if you're maybe wondering, still, I don't understand why that relationship is pertinent. Well, think about it like this, guys. S equals 2 pi r. How did I get 2 pi r? Think about it. Okay, so look at this. So my original formula is S all over r is theta, right? But if I go the full revolution, what did I just do? What is that length? You should be thinking something that starts with C and ends with umference. Circumference, okay? So that means this is the whole circumference. If I go the whole length, I just did a full revolution, okay? But I also just traced my circumference. So that means S then becomes 2 pi r because circumference is 2 pi r, right? And this is all over r. But then the r's go poofy. So that means that this is 2 pi and then equals, we know that that is 360 degrees, a full revolution. And if I divide by 2 here, divide by 2 here, what do I get? Pi equals 180 degrees. So this is why we use 180 degrees. Could we use 2 pi and 360? Yeah, we could. But the problem is it's not as simplified as it could be. Okay, I want to use the most simplified version or simplified formula, and that is pi 180 degrees, not 2 pi equals 360. Could you use these conversion formulas with 2 pi equals 360? Yeah, but it's not going to be helpful. So if that confused you at all, don't pay attention to that. Just pay attention to these. and then we'll move on, okay? All right, we're going to start now with degrees into radians. How do I go from degrees to radians? So we're going to take it really slowly. So 30 degrees. I want to multiply by pi radians all over 180 degrees. That's my formula. Go back to the next slide, and then you'll see that that's my formula, okay? Now remember that this is technically all over 1, right? And then the zeros go poofy. Now notice right here, the degrees go poofy because they're technically a unit, and we're cross dividing here, so the degrees go poofy. So what am I really left with? I'm left with 3 radians all over 18, which simplifies down to, pi. I forgot my pi. Don't forget your pi. Don't forget the pi. So 3 pi radians all over 18. So I'm really left with 1 pi radian all over 6. Do I really need to write the 1? No. So this is pi all over 6 radians. Okay, that's what I have. Perfect. Perfect, perfect, perfect. Now let's do the next one. Let's do a sky blue. So again, I want to do pi radians, and this is all over 180 degrees. Remember, this is technically over 1. The zeros go poofy, the degrees go poofy, so now this equals 9 pi radians all over 18. This simplifies down to pi all over 2 radians. Perfect. Perfect. Wonderful. Okay, last one. Pick a color. Yellow? Maybe some of you are like, that's so gross. I'm going to keep it. I probably don't do yellow that often. Don't worry about that period there. So degrees, right? So pi radians. And then this is all over 180 degrees. So degrees go poofy. Now you're probably thinking, well, junk, I can't do the zeros here. Because really now what I'm left with is negative 135 pi all over 180. How can I simplify that without being really, really frustrated? Well, 2 ways. Number 1, if you have this calculator, you can do it. This is the TI-36X Pro calculator. The thing I recommended, really, really nice for trigonometry. It's about $20 at Walmart. I highly recommend this. Why? Because they have fraction buttons here. I don't know if you can see. They have a fraction button. It's like right there. Right somewhere right there. I don't know. Somewhere. Okay? They have a fraction button, and basically you can plug it in, and it will simplify it for you. Okay? Also, most of you probably won't do that, which is fine. But you can also use a handy dandy tool called Desmos.com. Desmos.com will actually help you simplify it really, really fast. I'm going to show you how to simplify it. Now, obviously, you can simplify this just by using basic math. You can divide each one by 5 and go from there, right? But that's a lot of work when you could just have other calculators do it for you. Now watch. If I actually type in negative 135, I hit my backslash arrow right by the shift, right by the less than and greater signs, less than and greater than signs, and then go through 180, it will give me that. And you're like, Mr. Carlson, that doesn't freaking help at all. Just freaking wait. Click on this little fraction button, and it'll give you a fraction. Pretty cool, right? Now, if you're wondering, why didn't you put pi in there? If I put pi in there, guess what? It just gives me this whole long thing. Now, this is the decimal version of my radian measure. Sure, that's my radian measure, and that's the decimal version of it. And it doesn't really help me at all because it doesn't give me a fraction. And guess what? Math Excel will want a fraction, okay? So that's why I don't put the pi in there. So it's negative 3/4. So that means you can go over here. Now that you know it's negative 3/4, and you can say this equals negative 3 over 4 pi, and then radians. Now, do you put the pi on the outside? Do you put it on the top? What do you do? Technically, it doesn't matter, but I think Math Excel will want you to put it on top like this, okay? So that's mainly what they'll want. You don't necessarily need to have the radian sign, the radian units right there. I just like to make sure that we all understand it's in radians, okay? So again, to recap, you can divide by 5 here, or you can use your TI-36X Pro, and it'll simplify it for you. Just don't put the pi in when you're simplifying it on the calculator. And then if you don't want to do that, you can go to Desmos. Everyone has Desmos here. You can type that in without the pi, and then make sure you type in this fraction button, and it will simplify it for you. Then afterwards, you can add the pi symbol there on top with the numerator. Okay, I hope that helps. I hope that's clear, and I hope that allows you guys to kind of understand. So here, I'm going to do a checkpoint. So I want to kind of go through these 2 checkpoints and help you. And this is why the video is going to be really, really long. If you feel like you understand everything, I will have these in the PowerPoint slides. But if you feel like you understand everything, you can kind of skip through these checkpoints. But what I'm going to do is actually just pause here for a second, allow you to pause, and see if you can do these by yourself. So if you feel like you want to kind of check your answer here, then go ahead and do these by yourself. Pause the video, and then unpause the video, and I'm actually going to show you the answers here. Okay? I'm actually going to show you the answers. So go ahead, pause the video if you want. If not, just go do it along with me if you need extra help, or just fast forward and be like, no, I got this. I don't need to know this at all. All right, I'm going to start. So central angle in a circle has a radius of 12 feet. So I'm going to say R equals 12 feet. And then an arc length of 42. So that means S equals 42 feet. We want to know what the radian measure is, my theta. Again, I want to use my formula, theta equals S all over R. Okay. And so that means this equals, my S is 42 feet, and this is R. It is R, yes, but what's my R? Sorry. 12 feet. My feet go poofy, and then this so happens to reduce down to 7 over 2. Okay, which is approximately 3.5 radians. If you're still struggling with the radian measure and why I have that radian measure here when there's no units there, then just hold off. I will actually explain it later. All right, convert the next one. If you got that right, then perfect. You're awesome. Okay, this next one, we're going to convert each one. So I'm going to convert this. This is degrees to radians. So that means I'm going to do pi all over 180. Now notice I'm not going to put the radians here. I'm going to actually drop these out, but that's okay. I don't need it. The degrees and the zeros go poofy, so this actually equals 6 pi all over 18, which reduces down to pi all over 3 radians. Okay, this one, pi all over 180 degrees. Degrees and 0 goes poofy, so this actually is 27 pi all over 18, which reduces down to 3 pi all over 2. Perfect. And then this one right here, negative 300 degrees, I have pi all over 180 degrees. Degrees go poofy, 1 0 goes poofy, so this leaves me with negative 30 pi all over 18, which reduces down to negative 5 pi all over 3 radians. Okay, so if you got those correct, awesome. Amazing. Okay, you are truly vibing then. I'm going to race. Let's go. All right, now we did degrees to radians. What if I want to do radians to degrees? Let's hit it. So if I want to do radians to degrees, I just flip it. So instead of doing pi all over 180 degrees, I want to do 180 all over pi. Now, technically, again, this is radians. I'm going to kind of squeeze it in there. And the radians go poofy, and even the pi's go poofy. So what am I really left with? I'm left with 180 all over 3, which in this case is 60 degrees. Perfect. Notice how I keep the degree symbol there. Now let's go to the next one. So this is 180 degrees all over pi. I'm not going to do the radians here. I'm just going to basically expect you to know that the radians do go poofy. The pi's go poofy and everything. So I'm left with -5 times 180 degrees all over 3. Well, this equals -5 times 60 degrees, because 180 degrees divided by 3 is 60. And then this becomes 120 degrees. 120 degrees. Sorry, wow, what am I doing 120 degrees? I'm thinking of 12 times 5, and then it gets 60, so I'm kind of like, I'm not vibing too well. 300. 1 degree radian. Let's see if we can get it. So this is 180 degrees all over pi. The radians would cancel out here. The pi's don't cancel out, and then so really what I have is 180 degrees all over pi. Okay, that's really what I have. Technically, this is times 1 here. And this actually reduces down when I solve it, 57.3 degrees. Now you're like, how did you get that? Well, you see, kids, I used a handy dandy thing called Desmos. So if I do 180 degrees divided by pi, I can literally type in pi, and it gives me that, 57.3, rounded. Perfect. Last one. Now you may have noticed, well, there's some, like if it's radians, it will always have a pi symbol in there. No, that's not true. Okay, if it's radians, it won't have a degree symbol. So you know it's radians if it doesn't have a degree symbol. So that means just because it doesn't have pi doesn't mean it's not radians. Clearly, this doesn't have a pi symbol in there, but yet it's still radians. Okay, so I simplify that. The pi still stays there, but this is 2.3 times 180 degrees, and then all over pi. And the radians, if I actually wrote RAD right here, the radians would go poofy. This simplifies down to, I'll just do the math for you, 131.8 degrees. Perfect. Notice how they're all degrees, 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 degrees. Awesome. Let's move on. See if you can do this by yourself, this checkpoint. Okay, I'm not going to do the math. I'm just going to give you guys the answers for the sake of time, because this is going to be a long video. So go ahead and pause it, see if you can do it by yourself, and then come back. Or you can skip through this. All right, awesome. So these should be the answers that you have. 45 degrees for the first one. B is -240. C is 343.8 degrees, and D is -269.3 degrees. So if you got those, good job, amazing. Okay, if you're kind of struggling a little bit, don't fret, don't freak out. Okay, that's why we're doing it. It's practice, it's a checkpoint. Look back through your work, see if you have it. Okay, if you want to contact me to see my work or whatever, I can absolutely show you that. I'm just not showing it for the sake of time. Now, drawing angles in standard position. This is the second thing that we're going to be kind of going over, and actually the last thing, but I need to kind of go through this. Drawing angles in standard position. If I have an XY plane, so XY plane, and if I have a center, which of course this is the vertex, if I have an angle measure, let's just say this right here, 3 pi all over 2, this actually right here is 270 degrees. So what this is it's measuring 200, oh, so close. This is actually 270 degrees here. So this actually is 3 pi all over 2. This is the radian measure, that's the degree measure. Okay, right? This is the half revolution. You should already know what the half revolution is. It's pi, but it's also 180 degrees. And then the 1/2 revolution is pi over 2, which is 90 degrees. This is where we get your right angle from. Okay? 1/4 revolution, 1/4 times 2 pi gives you pi over 2 radians. Awesome. All right, let's erase this. Now, drawing angles in standard position. How do I draw angles in standard position? I'll show you how, class. So, pi over 4. If I have this right here, pi over 4, I'm really just going to, I know 45 degrees is somewhere in the first quadrant. So this is 45 degrees. This is theta equals pi all over 4. That one was actually really, really easy. So this is the terminal side right here. And this right here is your initial side, always on the positive x-axis. Okay, for alpha. Okay, alpha is a little bit kind of complicated. There's actually, let's do it this way first. There's two ways to do it. I'm going to show you the hard way, I think the hard way, and then I'm going to show you for C and D the easy way, the ones to keep in radians. So if you are like, I'm not so sure with radian measure, I don't really know how to deal with radian measure, I'm going to show you that it really has to do with fractions. Okay, just like in this previous screen, guys. So in this previous screen, you saw fractions here. So 3/4 revolution is that, 1/2 revolution is pi, 1/4 revolution is that. So you saw fractions there. So if we can kind of hone into our fractional abilities, we can actually just solve these without transferring them to degrees. But most of us do like degrees, and so we're like, okay, I don't know what that looks like, but I do know what it would probably look like using degrees because I have references with degrees. So I want to transfer it to degrees, and you can totally do this if you want to. All of these you can transfer to degrees first. Okay, now 4 goes into 4 one time. 4 goes into 180 degrees 45 times. Okay, so that means I'm left with 5 times 45 degrees, which gives me 225 degrees. So this isn't my answer, but this is the degrees, the measure in degrees of alpha. Okay, so this actually equals alpha in degrees instead of 5 pi all over 4. That's what I did. I transferred it to degrees. Now what we can do is try to draw this in standard position. What will that look like? Well, I know that this is 90 degrees, right? And this is why a lot of us like degrees, because of these references here. I know that that is 180 degrees. So that means if I go another 90, this is 270. Where does 225 lie? Well, it has to lie somewhere in here, right? So it has to lie somewhere in there, and this is 225 degrees. Or in radian measure, this is 5 pi all over 4. Okay? So that means alpha is this whole angle measure right here, this whole thing. I know it's kind of junky looking, but that whole thing, that's alpha. Okay, 5 pi all over 4 or 225 degrees. And then you would, on Math Excel, you would just select that one. Now, that I think is the hard way to do it. Personally, I don't like that way. I'm going to show you how to keep it just in radian measure and how to just use fractions towards your ability, like towards your benefit. So this is beta, negative 3 pi all over 4. So how do I do negative 3 pi all over 4 for beta? Well, if I draw my standard position out, pay very close attention to what I'm about to do. Okay, if I draw this out, 45 degrees, think about what this is. What this actually is saying is this is negative 3 times pi all over 4, right? It's negative 3 times pi all over 4. Well, I know, or I should know, because we did it already in this lesson, what pi over 4 is. Pi over 4, guys, pay attention, pi over 4 is 45 degrees. Well, I know 45 degrees is half of 90. And I know that this one quadrant right here is 90. So what is 45 degrees? Well, 45 degrees is half of it. It's half of this one as well. It's half of this one as well. And it's half of that one as well, all quadrants. Because if I take 45 times 45 times 45 times 45 times 45 times 45 plus 40, not times, sorry. 45 plus 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 45, I get 360 degrees. Okay? That's kind of working your way with fractions. Now watch. Watch. I'm going to do this in red here. I want how many pi over 4s? How many do I want? In the negative position, how many do I want? I want 3 of them. So watch. If it's a negative position, this is my initial. And my terminal side is going to go down because it's negative. It's not going to go above because it's positive. It's going to go down clockwise because it's negative. That's a negative angle. We learned that already. So now, guess what? I just have to count 3 pi over 4s. 1, 2, 3. Where does my angle lie? It lies right here. This is my terminal side, and this is negative 3 pi all over 4. This is beta. So that is how you do it without transferring into degrees first. If you're like, I don't know what that means at all, that's okay. Just transfer it to degrees first, and then use your reference angles, such as 90 degrees, 180 degrees, 270, to help you. Okay, do it that way. And if that helps, if that works for you, perfect. Just do it that way. If you're like, wow, that's actually really intuitive, I can actually use that just in radians, I don't need to transfer it to degrees, then do it this way. Okay, I'm going to show you the last one. 9 pi all over 4 for gamma. 9 pi all over 4 for gamma. What will that look like? Again, this is technically 9 pi all over 4s. That's what it's saying. 9 pi all over 4s. So that means each quadrant is again split in half. So since it's positive, I'm going to count 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, 9 pi over 4 again. So what will this look like? This is my terminal side, but that means gamma is all the way around. It goes all the way around. This right here is what we call gamma. Okay? That is gamma, and this equals 9 pi over 4. That's what it looks like in standard position. Now, if you're like, man, I really want him to show me how to do it in degrees. Okay. I will show you in degrees just so that you understand that it's literally the exact same thing, but I'll do it fast, okay? So in degrees, you have 180 degrees all over pi. Okay, the pi's go poofy, this goes poofy, and this becomes 45 degrees. So you really have 90, or sorry, not 90, 9 times 45 degrees. What is that? This is actually going to be 405 degrees. Okay, now that's going to be 405 once you do it. So now what do? I go all the way around because I know right here this is 360 degrees as a reference. But then I have to go an additional 45 degrees right here. And that will give you 405. Okay? So, is it the same position in the first quadrant? Yeah. Yeah, absolutely. So this is how you do it degrees. This is how you do it with just straight radians. All right? I will more than likely default to straight radians. All right? Unless you so otherwise ask me. Okay? I know that took a while, so I'm going to erase. Go ahead and do a checkpoint here. I'm not going to, again, show you how I get to the answer. I'm just going to show you the actual standard position. But go ahead and pause the video, see if you can actually do it yourself. Okay. All right, welcome back. So this is what they look like. This is them in standard position. You have negative pi over 4, just goes down. That's actually really, really easy. And then you have alpha. So it's basic. I think that's about 120 degrees. and it looks like it's in the second quadrant. This one is in the first quadrant, but goes all the way around here. So follow my cursor. It goes all the way around. All right. And notice how I kind of had a count. I had to count 7. 1, 2, 3, 4, 5, 6, 7. And it's right there. And then this one is actually pretty complicated. It's 13. So I had to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. 13. Now, if you're also wanting to think if you're really, really good at fractions, usually I don't explain it this way because students get really confused. But for those of you who are solid at fractions, how many times does 4 go into 13? It goes in twice, which means you know you will have to go around technically twice. This is not technically the right angle. So technically it's this. Actually, let me erase this. I didn't technically do it correctly. It goes around twice. So this is once, and this is twice, and then just a little bit extra. Okay? And so it kind of goes around a lot. So 1, 2, 3, 4, 5, 6, 7, 8. It goes around a lot. All right. Let's move on. Common angles. I already showed you this, so don't write this down. We are going to deal a lot more with this later. Okay, this is actually what we call the unit circle. These are common angles. And in 2-something weeks, we're going to get into this. This is what we call the unit circle, but don't freak out because I will teach it to you, and we have a whole day dedicated to it, to how what angles are which and how we get those angles and so forth. So don't worry. Okay. And then this is the negative angle. Again, don't worry about that. All right. Raise coterminal angles. This is our last thing that we're going to be touching on, and then we'll stop. All right, coterminal angles. What is it? Angles that have the same initial and terminal sides. So they are called coterminal. If they have the same initial and terminal sides. So for instance, right here, alpha. I go right here, sort of. And then beta, I go right here. Now notice this. Ready? Ready? In green. They have the same initial. This is the initial side where it starts, the positive x-axis. That's the initial side. And they also have the same terminal side. Same thing here. Same initial side, same terminal side. Okay? Alpha is right here, but beta has to go all the way around to do it. So, what are coterminal angles? Alpha and beta are coterminal angles here because they share the same initial and coterminal sides, even if beta has to go around all the time. So that kind of begs the question here. If I erase all this, think about it, guys. Does that mean there are an infinite amount of coterminal angles? Yes, because watch, I can make another coterminal angle going all the way around and then boom. Okay? Or I can erase this and I can make another coterminal angle for beta to go all the way around and then boom. All right? Or I can go all the way around, all the way around, all the way around, all the way around, and then end right there. That's a huge angle, right? That's probably at least 720 something. Boom, 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 and then finally something. But hey, is it a coterminal angle? Yes, because it shares the same initial and terminal side. So we're not going to be doing that much. We're going to be doing very, very basic coterminal angles. And how we do that is literally just by adding and subtracting multiples of 360 or 2 pi if it's in radians. So we have this first example. Assume that the following angles are in standard position. Thank you. Find the positive angle less than 360 that is coterminal with each of the following. Okay, how do I do that? Well, for the first one, all I have to do is literally take 420 degrees and minus 360. This is all you do. And this equals, of course, 60 degrees. So what's my coterminal angle? It's 60 degrees. If I wanted to plot this on my standard position, okay? Now 420 degrees is all the way around. That's 360. And then plus an additional 60. So then this is what 420 looks like. Pretty crazy, right? 420. Now, 60 degrees, though, is just this. It doesn't go all the way around. It's just that. So this is 60-degree angle. But does it share the side? Yes. Does it share the terminal side? Yes. Is it coterminal angle then? Yes. Now, for this next one, for a negative 120, now watch, if I graphed it first, instead of actually solving it using mathematics, if I graphed it first, negative 120 is right around here. Notice I'm going down because it's negative. Okay? If I wanted to find the positive angle, less than 360, okay, that means I can't go this way because that's negative, and I can't go all the way around multiple times because then it would be greater than 360. That means I need to do this, guys. My positive angle, less than 360, is what's in red, that angle. And then we're like, how do I know what that angle is? Well, we take a negative 120, and then we don't subtract it. We don't subtract it. We actually add it. So add it to 360. And this actually equals 240. So what is my angle in red here? This is 240, whereas my angle in blue here is what we said was negative 120. Do they share the same initial side? Yes, they do. Do they share the same terminal side? Yes, they do. That's what makes them co-terminal. Co-terminal, co-worker. I work with you. These angles are working together. Awesome. All right, let's go through some radian measure here. Okay, let's go through some radian measure. And again, always, like, if you feel like you understand this completely, you can always skip ahead to this video. I'm just making this, I'm going through all the examples. So what do I have? Well, the first thing I need to just write it down, and I'm going to subtract, not by 360, but by 2 pi. And the reason why I'm doing that is because 360 is 2 pi radians. And so in order to do that, I need it like denominators. So times 6 gives you 12. What's 17 minus 12? That is going to be 5 pi all over 6. That's how you do it completely mathematically. And I am going to do this mathematically. I'm not going to do it. I'm not going to plot radians on the thing. I can't. I'm not going to do that, and I won't do that. I can do it, but I won't. How do I do it this way? Again, I'm not going to subtract it because then it's not positive. I need a positive angle less than 2 pi. Okay, so it can't go past 360. It can't go past 2 pi. Okay, and we know that 5 pi over 6 is not past 2 pi because 5 doesn't even go into 6 1, or it goes into it once, but it doesn't go into it twice. Okay, so since 5 doesn't go into 6 twice, I know it's not past 2 pi. So, and I can't do a negative here. I can't do negative 2 pi here because then it would just make it more negative. So I need to add 2 pi here. But if I add 2 pi, that means I need common denominators. Times 12 gives me 12. Times 2 times 12 gives me 24. And so that means negative pi plus 24 pi, negative pi plus 24 pi, what does that equal? That gives me 23 pi all over 12. Now, do I know that, do I really know that this is actually less than 2 pi? Well, I do. How many times does 12 go into 23? How many times does 12 go into 23, guys? Just once. It doesn't go into it twice. If it went into it twice, it would be above 2 pi. Just like this, the 6 doesn't even go into 5 once. The 5 goes into 6 once, but either way, it doesn't go past 2. Okay? So those are your answers. Awesome. Let's erase. Here's some more examples. I'm gonna go through these really fast, guys. I'm really fast. So 750. I'm gonna take 750 and then I'm gonna minus 360. Okay, and so that is 390. But here's the problem. I want a positive angle less than 360, and 390 is not less than 360. So that means, guess what? I need to subtract again. I need to subtract 360 again, and finally I get 30 degrees. Perfect. Next one, 22 pi all over 3. So I'm going to take 22 pi all over 3, and I'm going to subtract 2 pi. So this is 1 times 3 gives me 3 times 3 gives me 6. 22 minus 6 is going to be 16 pi. 16 pi all over 3. Now, here's the question. Does 16 pi all over 3 go past 2 pi? Well, you have to ask yourself one important question. Are you ready? How many times does 3 go into 16? A lot. So it's definitely past 2 pi. So I need to subtract again my 2 pi here. But I'm not going to write 2 pi because I already know that 6 pi over 3 is 2 pi. So this helps me a lot better. So what does that equal? Well, that equals 10 pi all over 3. Now, does 3 go into 10 more than twice? More than 2 times? Yes, it does. So that means I need to drag it down here, 10 pi all over 3. Do it again. So this is our third time doing it. And now that this is 4 pi all over 3. Now, does 3 go into 4 2 different times or more than 2 different times? No, that's my answer. Great. Negative 17 pi all over 6. Let's go to town on this. So I want to add 2 pi here. This is 1 times 6 gives me 6 times 6 gives me 12. So negative 17 plus 12 is negative 5 pi all over 6. Okay. But here's the problem. This is definitely less than 2 pi, right? This is less than, or this is definitely, yeah, it's less than 2 pi. But the problem is it's not positive. So since it's not positive, I need to make sure to do a little bit more math. I need to plus 12 pi back. So I need a plus 12 pi all over 6 back to this. Okay? I need a plus 12 pi over 6 back to this. And what this then equals is 7 pi all over 6. Now, does 6 go into 7 more than 2 times? No. Is it less than 2 pi? Yes, because that's what we said. And is it positive? It is. So this is our answer. Okay? All right. Let's do pink for the last one. Negative 10.3 angle. So all I have to do is 10.3 angle. Now, am I going to use 360 or am I going to use radians? I'm going to use radians. Okay, because if it was degrees, it would have degrees there. Since it does not, I'm not going to do that. So it is radians. So I'm going to take negative 10.3 and then plus 2 pi. Okay, so then this will equal negative 4.01. All you have to do is just plug that into Desmos and it will give you that. The problem is it's still not positive. So because it's not positive, I need to take plus this 2 pi again. So I need a plus 2 pi once more, and this will actually equal 2.27. So I need to do it twice. And that is my answer. This is great. Awesome. We're going to town on this. All right, checkpoint. See if you can do these checkpoints. These are the last things we do. So if you're solid, if you feel like you understood this, you don't need to go through the checkpoint at all. Kind of just fast forward to the end of the video. Go ahead and pause it, and I'll show you the answers. Try it for yourself. All right, welcome back. These are the answers. I actually went ahead and went to checkpoint 6 as well. So the first one for A is 40 degrees. Next one's 225. Checkpoint 6, A is 3 pi over 5, and this is 29 pi all over 15. So if you got at least 1 or 2 of these, then you're awesome. You're on your way to being a mathematician, a real trigonometry mathematician. Okay, let's continue. And then I have just this one. So go ahead and pause the video. I'm going to share with you the answers again. All right, these are the answers. For A, you got 135, 5 pi over 3. For C, B, you got 11 pi over 6. And then you have a coterminal angle of 4.84 radians for D. So these are the coterminal angles. Notice how I have radians here because this is a radian. Remember, if it doesn't have a degree symbol, it is automatically radians. Okay, just because it has a pi does not mean it's radians. If it doesn't have a degree symbol, that's what it means to be radians. Okay, and I also gave you the degree symbol, the degrees there for just for good measure. Get it? Good measure? Ha 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 ha. All right, so let's erase. Fantastic. So what did you learn? And this is a long, long lesson. Again, I think this is probably one of the longest lessons you will ever have for trigonometry, but that's okay. What did you learn in 5.1a, angles and radian measure? So you recognize and use the vocabulary of angles, degree measure, radian measure, converting. You drew angles in standard position, and you found coterminal angles. Go ahead and pause the video if you need to get that in your notes for your summary, because you need summaries now, so make sure you write something along these lines for your summary. Great. So make sure that you are getting all your assignments turned in, your Math Excel orientation down there, your honors contract. Please contact me through a parent guardian, through email if you're interested in honors. Signed syllabus acknowledgement form, that is due on Wednesday, 8/5 by 4 p.m. And then make sure you actually complete your Math Excel homework assignment. We will have a homework quiz about this tomorrow, or if you feel like you can kind of go through the homework tonight and then even do the homework quiz even tonight as well, then go ahead and do that. It's all mandatory for everybody, so you have to take the homework quiz. All right, guys, that was a long video. Thanks for just keeping up with me. Until next time, I'll see you guys. I'm Mr. Carlson. Peace.